Okay, we're on to number 3. Hopefully you are able to view this. I just realized that some of you couldn't see yesterday's videos and I hopefully fixed it, but it's a definite learning curve for me. I luckily have nice family and friends at work that help me, but not my thing at all. All right, so again, we're doing substitution. And I'm looking for a variable by itself in one of the equations. So a system has 2 equations and 2 variables. And if we look at the second equation, I have x by itself. So I'm looking for a variable by itself. I have that x. So I'm going to replace the x up here in this equation with what x is equivalent to, which is 2y minus 3. Everything else in the top equation stays the same, so I still have a minus 4y, and it is equal to negative 6. I'm going to distribute. And this one is interesting because if you notice, you get, when you combine like terms, you have 4y minus 4y. Those drop out, and you don't have any y's left. And what is left is a true statement. So when you have that happening in a system, a true statement means there are infinite answers. So we're going to say infinitely many answers. And that might sound weird to you. That doesn't mean everything is a solution. It just means there are infinite answers, there are solutions. So what's really happening in a situation like this is you have, if you were to graph the line, like, I have to think about it. Like the line would be graphed something like this. And the second line is that same thing. So any point on that line is a solution. So there are infinitely many. There are infinitely many that are not solutions. All those ordered pairs that are not on the line, those are not solutions. But anything that's on the line and there are infinite points on that line are solutions.